Okay, everyone. So now we're going to look at how we can do some basic measures of central tendency on our data set. So I'm going to do a quick peek and see how many rows I have. I have quite a few. So not even getting all the way into my data set here. I aimed for one day and I have almost 60,000 rows, right? Which is a lot more than I want to deal with. Again, we're just doing this sort of for the purposes of the exercise. Even frankly, I think looking at an entire day is going to be kind of a lot. So I'm going to just edit this down. I'm just going to go with the first 10,000 rows. Again, this is totally arbitrary. You would need to be much less arbitrary or not arbitrary at all in determining how much data to look at. If you were doing an analysis, you would need a rationale, right? You would need a reason why you looked at a certain time period. Those of you who are in the science program, I'm sure can relate to this. A lot of the debate about climate science has been about, what time range are we looking at? I don't know if that's still a current debate, but it has certainly come up in the past of, why are we starting at X point in history, right? We always have to have an explanation for, and a well-reasoned explanation for why we are beginning or ending at a certain point in time. So I'm going to come up here. I'm just going to, keeping in mind that that my first row is actually headers. I'm going to go straight to 10,001. Okay, and if I just look at this, what I can see is that this takes me through about the first 11 and a half hours of the day, right? So 10,000, basically what we can infer from this is that in the first 12 hours, that is between midnight and approximately 11:40 in the morning, there were roughly 10,000 city bike trips in the city of New York, which is pretty impressive, right? I think we all know that New York is a big city. City bike is a popular program, but it's not mass transit, and yet even in 12 hours, there are 10,000 rides. So what we're going to do here is the metric that I'm going to look for my mean and median on. For this example is going to be the trip duration, right? Now, I could do this just sort of across my general 10,000 rows, but that's not really going to give me much insight, right? It stands to reason I need to have a well-formulated kind of hypothesis or question that I'm looking at, right? So what I want to do is I want to look at, I'm going to say, what was the average duration of a ride that was taken from a particular starting station, right? In other words, when people start in place X, how long do they usually spend on the bicycle, right? And, again, there's any number of reasons why we might want to ask a question like this. Eventually, we'll want to be able to explore the relationship between start stations and end stations. But for this first purpose, what I'm going to do is I'm going to take my file here, and in order to isolate all of the trips that started at a given station, I am going to perform a sort. Okay, now the way that I do this is I'm going to highlight. You may have noticed, again, depends on how much experience you have with Excel. So if I select up here, sort of in the gray bar area, this will naturally select everything in those columns. And if I come to my data tab, I can, I'm going to be sure to choose the little small arrow down here. No. And I'm going to choose custom sort. And the reason why I'm going to do that is because I want to specify which column I'm doing the sort on, right? So the data is already sorted according to the start time. I now want to sort it also on the start station ID. And you can see very helpfully it provides me with the column headers. It infers that there are column headers there. And I'm going to say smallest to largest. I don't really care at this moment. And we can see that my first start station ID is start station 72 at West 52nd Street and 11th Avenue. So for me, what I'm going to do is I'm just going to focus on that for now. I am going to get rid of, in fact, what I'm going to do though, in order to not lose all of my data or all of my other data, I'm going to go ahead and copy this. You can see this is a reasonable number, it's about 34 rows. I'm going to copy this. And I'm going to come down here and create a new sheet, and I'm going to paste my data into that new sheet. Now, at about this point in time, there are a couple things that happened. First of all, my original data file is, as we can see, is a CSV file. Now, CSV files by themselves do not support multiple sheets. The idea of having multiple sheets constitutes a quote-unquote workbook. This is exactly what Excel was designed to support, is having things like more than one sheet. So I'm going to need to save this. So I'm going to save it with a different name. And I'm going to specify, again, I think I'm going to say make this an Excel format, and I'm going to say July 17th, City Bike, Station 72 analysis. Okay, so you can see I am intentionally giving this a descriptive file name because I'm probably going to need to find it later, right? And it's very quickly, even in the course of doing these explorations, I've already generated 4 or 5 different files, right? It's very easy for files to accumulate. You need to have a naming convention. And, you know, it's up to you what naming convention you use, but I strongly suggest that you work on developing one that is easy for you to follow and understand what's going on. However, naming conventions can only get us so far, and that is why we are going to be starting a separate file right now. And I'm, again, just going to do this with text edit. Okay, and this is just going to be my methodology file. So I can leave this as a rich text file because I'm literally just going to be writing down what steps I take. So I'm going to say July 17 City Bike steps. Okay, so this is now my documentation file. This is my process file. So the first thing that I'm actually going to put in this file, right, I should have been doing this the whole time, is I'm going to say something like download file named 2017-07 City Bike trip data .csv.zip from that URL, right? And then I would say something like open with text edit, delete below 0701, right? And so on and so forth, right? So this entire time, what I should be doing is keeping just a running log of all of the things that I am doing to this data. And the reason for that, again, as we discussed in class, is this issue of reproducibility, the ability to go back and duplicate the steps that we took to do our analysis of a file, for example, or of a data set. Again, it may seem in the beginning like you'll totally remember the URL where you downloaded that file, and I guarantee you, you will not. So this, again, is the thing that does add 40% in terms of time to our effort, but it saves us 2 to 4 times that amount, and certainly more than that in stress, to do it ahead of time rather than doing it, trying to recreate it afterwards. So this is just a preview that for your assignments, you will be doing this type of analysis. Your process file will be possibly the more important part of that assignment. We'll be documenting each step that you took in the process. And it should be this specific. I should be able to sit down and recreate exactly your results, exactly your process by reading that file. So perfectly fine to have it be in plain language. It doesn't need to be technical, but it just needs to be descriptive enough that I can duplicate the process. So having done this, I now have, I'm going to call this, edit, rename, I'm going to call it Station 72, okay? And now I can start to do some of my analysis, right? So very simply, as I said, what I'm going to first look for is trip duration. Now, happily, trip duration, when I'm looking for the mean, the arithmetic mean, this is the kind of thing that most of us remember. It is the average, okay, which is add them all up and divide by the number that you have. So I'm going to just label this here. I'm going to say average trip duration, okay? And so I can just click in a cell, and again, you know, I welcome any questions. You can post them to Piazza before class if you like. We'll certainly go over this in class. The way that I do this is I'm just going to click in a cell, and I'm going to use some formulas, okay? And so formulas, the way that we indicate to Microsoft Excel that we're about to use a formula is we start with an equal sign, okay? An equal sign means to Excel a formula is coming. And the formula that I'm going to use here, just to start, we're going to do all these things very manually to start, and then we'll talk about how they can be, how we can use shortcuts. Let's start to sum. I'm just going to add them all up, okay? So I can just highlight the rows that I want to sum. That's great, okay? And then I want to divide it by the number of rows that I have. And how do I know how many rows I have? I can sometimes find it a little bit counterintuitive when there's a header row, but I can see that the last labeled row is 34. I know that my first row is my header row, so I infer that I have 33. I can simply subtract 1 from 34. Also, sometimes I just find this handy that when I do this highlight, it's actually counting the rows for me in the upper left, in that very upper left area, confirming that I have 33. And so here we go, it's going to be 33, okay? So the average trip duration is 1,235 seconds, 1,236 seconds really. One thing that I will point out when we are not using something like the mean as an interim calculation step, but we're just saying this is what the mean is, it's important to note that we cannot add precision by doing math. And what do I mean by that? What I mean is that the closest measure of the duration of these trips is to the second. Okay, this is 775 seconds, 337 seconds. I cannot infer that, I cannot, by doing math, I cannot get a higher precision. I can't get something that's more specific than a single second. And what that means is that I would actually need to round this value, right? So my actual, oops, that was the formatting issue. My actual value here is actually 1236. And I can get this to show by putting first the round in front of it. Oh, I think it wants me to, I thought I could do that, and it wants me to know how many digits I want to round to. Okay, and I get 1236, yes, which is what I expected. Okay, so a little bit on the syntax of using formulas in Excel. I talked about how that equal sign signals to Excel that there's a formula coming. The other thing I want to point out here is the round parentheses. So the round parentheses in Excel formulas function a lot like our curly braces in JSON, right? It encapsulates something and says these are the things that belong to this formula. So in the case of the sum formula, right, what we can see is that we had the sum formula, and then we opened a round parentheses, and then what we entered into it, although we used that keyboard, that sort of interface shortcut of highlighting, we said start at cell A2 and sum everything between A2 and A34, and then when we have finished that, right, we close the circle by having that right round parentheses. And then when we want to divide that by something, we can just put a division sign and then the count that we need to. So that's how we're going to do our mean. We will come back in a few minutes with our median and possibly move on to some of our measures of central tendency. So see you back in a moment.